Some logarithms, such as the first one here, could actually be done without a calculator. This is log base 10 of 10,000. So that's asking 10 to what power gives us a 10,000. 10,000 is 10 to the fourth, since there's 4 zeros. So 10 to what power gives 10 to the 4? That obviously would be a 4. Now, you're not doing that on either of these. So, we best use our calculator for evaluating most logarithms. On the left-hand side of the TI-84 keypad, right next to the 7 key, is the LOG key. Notice when you press the LOG key that you also get a parentheses. That is a design of the calculator that you cannot alter. So even though our problems say, for example, LOG 10,000 without any parentheses, we have to type a 10,000 in the parentheses. So there's the LOG of 10,000 on the TI-84. Here is the LOG of the 341. And here is the LOG of the 0.06894. And those are numbers that may need to be rounded off to a certain number of decimal places. One application of logarithms is from chemistry, and it has to do with the pH of solutions. As you probably know, if you've ever done stuff in the kitchen before, some things are acid, some things are base, and the pH together is a single quantity. Could have been a single letter, but chemists used 2 letters for that. The whole expression H3O with an exponent of a plus sign likewise is a single quantity. Notice there's a minus on the front of the LOG, that's part of the formula, and that the base is actually a 10 since it's not written. So here's how we would do this problem. We'd take our formula and substitute this value for this quantity. Therefore, we would have pH equals negative LOG of 6.8 times 10 to the negative 8. Now, we'll type that into our calculator. Be sure to use the negative that's on the bottom. The LOG 6.8. You can literally use the times key. 10 with the exponent of negative 8. Traditionally, we use 2 decimal places for pH, which would make that 7.17. Using the formula, we need to solve for the hydronium ion concentration by using a 4.3 in place of the pH. Remember, log without a number is base 10. We're going to transform this to exponential form, but first we need to deal with the minus sign on the front of the log. Multiplying both sides by -1 makes this a negative 4.3, and this is now in standard logarithm form, which we convert to exponential form. Here's the base. The logarithm is the exponent. And then here's what's left, which is what we're trying to solve for. So we need to do the 10 to the negative 4.3. On our calculator, 10 to the negative 4.3 looks like this. Notice how we have this E at the end. In scientific notation, that's 5.012 times 10 to the negative 5. Like with the base 10 logarithms, there are some natural logs that we could evaluate by hand. The ln means log base e. So the log base e of e to the fourth means e to what power gives e to the 4. And obviously that comes out to be a 4. The other two, however, we could not figure out just in our head. So again, we need our calculator for this. The ln key is on the left side of the keypad next to the 4. And so the ln of e to the 4 is 4, just like we just figured out. The ln of 341, notice if that's all we're typing, we don't need to close the parentheses. And the ln of the 0.06894. And again, rounding off may be something we would need to do. As long as you can remember where to find the right keys, you should not have to use the change of base formula if you have a TI-84. In the math menu, way down at the very bottom, which you can get to quicker by going up, and it starts over at the bottom, there's a key marked log base. That produces the logarithm template, which we can fill in with the numbers that we're trying to do. Here is the log base 4 of 20. Likewise, math, up, enter. Here is the log base 2 of 0.7. And here is the log base 9 of 794.